Hi everyone, Henry Tegeki here with my colleague Alvin, and we're going to discuss the second machine learning assignment, which basically talks about three concepts: Bayes' theorem, naive Bayes, and Bayesian networks, and how they relate to our use case, which is medical triage optimization and prognosis analysis in the domain of health. Some of the aspects we'll cover will be: one, we'll describe the problem, talk about the data set that we chose, why we chose it under feasibility, then talk about some of the key features in our data, go on to talk about the three concepts: the Bayesian theorem, naive Bayes, and Bayesian networks, and later on compare the three of them. Over to you, Alvin.
Yeah, thanks, Henry. So maybe to just give an introduction to the problem. So triaging is basically a medical process that rapidly assesses patients to identify their level of need for medical health care. So some patients will need emergency attention and others might be able to wait in a queue. So this process is considered a very important step, especially in emergency management in hospitals and also in pre-hospital emergency care. So I guess intuitively you can already ascertain how any mishaps in this process might be an issue or dire. And there are already a number of documented challenges existing in the process, which usually stem from like personnel capabilities, hospital protocols and resources, and other issues. So the idea is to explore the possibility of leveraging machine learning to mitigate some of these challenges. So a quick overview of the data we're using the MIMIC data set, which contains about 112,000 clinical reports documenting things from a patient's vital signs and medications and procedures performed and length of stay, say, in the emergency department, and so on and so forth. The reason why we chose this data set stems down to one, the relevance in terms of its scope and context, especially to our use case. Two, its usability, how the data is structured and the documentation that supports the understandability of this data. Of course, the size, if there are a sufficient number of data points to be used for our use case. And the quality of the data in terms of accuracy and completeness, in terms of missing values, and so on and so forth. Yeah. So the key features that we look at in this data set are: one, the hospital module, which documents all the electronic data collected through all sections of the hospital in terms of laboratory management, medical prescriptions and bill diagnosis, and so on and so forth. The second module looks at the ICU module, which looks at things that happen within the ICU unit. So IV administrations and monitor charts and ventilator settings. And then lastly, we look at the ED module, which carries the gist of the data that we need for this particular use case actually. So when you talk about the triage assessment and the vital signs that were recorded, the reasons for admission, what the chief complaint was, if there was injury, trauma, and so on and so forth. So these are the three modules that sum up the data that is relevant to our use case. So jumping into the three concepts, we shall kick off with Bayes' theorem. So Bayes' theorem is basically a mathematical method used to determine conditional probabilities. So what is the probability of one event occurring given that a certain event has already occurred? And that's the general idea behind it. So in a machine learning context, it can be posed as in this case. We can say what is the conditional probability of a certain class label given some sort of data. And in our use case, we can look at it as, because our classes are basically the levels of risk or triage classes. So what is the probability of a patient's triage class being what it is, given their medical history and or current medical situation? Secondly, we dive into the naive Bayes, which is a probabilistic classifier that is built off the Bayes theorem that we have discussed earlier. And I think the unique property of the naive Bayes is that it makes strong assumptions about the independence of the independent variables in a data set in regards to their contribution to the target variable or the class variable. So in our use case, an example can be structured as such. So if we have features such as the vitals, trauma, and consciousness, to ascertain whether a patient is at high risk and so on and so forth, a naive Bayes classifier would consider each of these features independently in terms to how they contribute to what the classified level of risk the patient will be at. Yes, so as discussed earlier, we would use the naive Bayes approach in our context to classify these patients according to the triage levels. And the interesting insights we'd hope to gather from this is how each of these features independently contribute to a person's risk. So how does a person's recorded vitals contribute to their, let's say, triage class as being high risk or urgent, and so on and so forth. Yeah.
Yeah, the other aspect that we will talk about is the Bayesian networks. And well, these are probabilistic graph models that explicitly capture known conditional dependencies with directed edges in a graph model. So how this work is they try to map the different features in form of nodes and then establish relationships between these features. Those are the links, and in turn show how the different features will eventually lead to the predicted outcome, or in this case, our classification problem. Yeah, so in terms of how we are going to apply, or how we plan to apply this in our use case. So we intend to use Bayesian networks as a form of exploratory data analysis to study the relationships among the variables and how they contribute to the criticality of a patient's condition during the hospital triage scenario. And maybe key to note is these Bayesian networks also help to simulate different scenarios. So we can try to compare the different parameters, give them different weights, and then still find how their contribution is to the final outcome. Yeah, so the next part will be comparing the different algorithms, the different concepts. So we'll start with the Bayesian theorem versus the naive Bayes. And the biggest difference, as the previous speaker noted, was one, the Bayesian theorem, we assume conditional dependency of the predictor variables, whereas the naive Bayes assumes conditional independence of the predictor variables. And what this simply means is during the Bayesian theorem, the different features can actually have implication or dependencies on each other. So an example would be when classifying the criticality of a patient in our triage scenario, based on features like heart rate and signs of injury or length of stay. These very features that we're using could actually have conditional dependencies on each other. So maybe signs of injury could actually in turn affect the length of stay of a patient. Whereas for the naive Bayes, it strongly considers that these different features under study are actually independent. Yeah. Then the next comparison is naive Bayes versus Bayesian networks. So naive Bayes, like we saw still, considers independent contribution of a predictor variable to the final outcome, while the Bayesian network simply models relationships between the features at a very general level. And importantly, the Bayesian network needs a lot of data for it to derive these, relationships compared to the naive Bayes. Yeah. Then the last part is really some of the reference materials that we used along the study or along the research. And key to note was an article by Sharon E. and Thom Meyer, where they were talking about the triage, basically the concept of the triage, and this gave us a big background information on how it's currently being done in the pediatric emergency medicine space. We also looked at effects of interruptions in triage process in emergency department by Johnson and Gillespie. And also our last part was the source of our data, which is mentioned here. Yeah, thank you.